Didn't tell me to hit the record button.
Oh, it's not showing up on the thing anymore.
Oh, it's down here now.
Oh, okay.
I had to move it. Anyway, that's okay. I remembered. All right, so what is a buffer? A buffer helps neutralize the pH. A great example of a buffer would be sodium bicarbonate. When you have an upset tummy, you're producing too much gastric acid. You take a Tums, that's sodium bicarbonate. And it helps to reduce the amount of acid and it helps to neutralize the pH. We talked a little bit about cows yesterday. Cows are delicious but disgusting because they create like 20 to 25 gallons of saliva per 24-hour period because they have a very high concentration of this sodium bicarbonate in their saliva. As they are ruminating, meaning regurgitating, regurgitate is different than vomit. Regurgitate means kind of a meaty burp. You know when you eat your Chipotle burrito too fast and you burp and you get that little fun meaty surprise at the end? You chew it and you swallow it? We've all done it. We've all done it. Don't you look at me with judgment in your faces. You swallow it. Yes.
You just, yeah, I don't chew it.
Well, it depends on how chunky it is.
Oh. That's even worse.
You know, like if you have your Chipotle burrito that has the cube chicken and you burp and there's a whole cube of chicken, I'm not gonna swallow it whole again. Give it a little, it's still got some flavor on it.
Oh, gosh. Do you see it that way?
It's still got flavor. Come on, TV audience, back me up here. The chicken Chipotle burrito, a little bit of flavor. It's still just a regular piece of chicken. It's not anything. I just ate it too fast. Give it a little chew. Get some of that flavor out of it.
No.
Really? Avery, we're looking at your face and they're all laughing. Okay, so apparently it's just me. Well, ruminants do chew it. Well, chewing their cud. But because they're constantly regurgitating, the caudal end of their esophagus is not protected. And so they have this sodium bicarbonate, this buffer, that helps to keep that pH neutral so that they don't end up with some sort of perforation, some sort of ulcer. We started talking about organic molecules. Organic molecules, remember, do have a hydrocarbon backbone. That is the definition of an organic molecule, that it has this hydrocarbon backbone. Inorganic does not. Tell me an example of an inorganic molecule. Add something to that hydrogen and you got yourself a correct answer. How about you take a hydrogen, add another hydrogen and an oxygen?
Dihydrogen monoxide?
Yeah, dihydrogen, which is water. Which is water, guys. Water is an inorganic. It does not have any carbon to it. Now we've added a little sprinkling of carbon. We have 4 groups of this organic molecules: carbs, lipids, proteins, and nucleic acids. And so we're just going to go through handshake. How do you do? I get a little excited about this because this is a lot about nutrition.
Before we move past the carbon stuff, so carbon helps things like be alive, right? Like what is an example of something with the carbon that we have?
Carbohydrates have a carbon, fats have a carbon, all of these things that we're just talking about. The hydrocarbon chain is what makes it organic. No hydrocarbon makes it inorganic. That we're just dealing with definitions here. The 4 categories that I just went over, the carbohydrates, proteins, fats, and nucleic acids. These are 4 examples of organic molecules. And when I say the word organic, now this is different than, oh my God, I got organic tomatoes at Trader Joe's. That's not what I'm talking about. That is a process to farming. This organic means it has that hydrocarbon chain somewhere in it.
Is that like having nutritional value?
So yes, it is the hydrocarbon chain that tells my body what to do with it. And in fact, it's the hydrocarbon chain that can have single bonds. Sometimes we'll have double bonds, and that double bond will tell my body what to do with it. We're going to talk about that when we get to accessing fats and fatty acids. We're going to talk about the double bond, and wherever the first double bond is, that's what says, hey, body, here's what you're going to do with this. So yeah, nutritionally, those hydrocarbon and the bonds that connect them, super, super important for telling your body what to do.
So what are some examples
Of what?
of the hydrocarbon bond?
I'm doing them right now.
Inorganic.
So I just said water is an example of inorganic. All of the ones we're talking about right now are organic. They have the hydrocarbon, carbohydrates, fats, proteins, and nucleic acids. So these carbohydrates, these are known as sugars. And this is just sugar. These sugars have to be broken down into a single sugar molecule. This sugar molecule can be bonded together. If I have two sugar molecules bonded together, that is going to be a disaccharide. Di meaning what? Two, saccharide, sugar. If I have more than two bonded together, I have many, polysaccharide. And the more molecules I have, the more bonds I need to break, the more energy my body has to use to do it. Breaking bonds takes energy. If I have a monosaccharide, there's no bond. My body does not have to. That's coming down today. My body has no bonds to break. I don't need any energy to use this. Disaccharide, I have one bond to break. Polysaccharide, I got a whole bunch potentially of bonds to break. The more bonds I got to break, the more energy I'm going to use to do that. And then I think yesterday we talked a little bit about lactose, didn't we? Yeah, and how lactose is a disaccharide, but those of you that are intolerant cannot break the bond. What does your body do with stuff it can't use?
Throws it.
Gets rid of it, gets it out of the colon.
So is that why when you eat like saturated fat, you gain more like weight?
Oh my God, put a pin in that for just a second, because fats are different than carbohydrates. I'm going to talk about fats here in just a second and the different different makeups of the fats. So put a pin in that for just 1 second and I'm going to answer that. Just terminology. To anabolize, anabolism is to build up, catabolism is to break down. The way that I remember it is probably not the way that many of you can. I'm a big football fan, huge football fan. I'm one of those football fans where I watch all 3 games on Sunday. I'm watching the one on Monday. I'm watching the one on Thursday. I watch them all. Because I don't just watch my favorite teams. I watch them all. It's like the greatest soap opera ever on the planet. It really is. If you approach it like that, football really is like a soap opera. It's just fabulous. Yeah, American football. No, I don't follow Canadian football. I used to, but I don't anymore. The Argonauts kind of lost. That's what the Toronto team was, is the Argonauts. So anyway, American football. We used to have a defensive player named Brian Cushing. He got caught twice doing steroids. He was trying to build himself up. He was trying to make big, huge muscles. He took anabolic steroids. And then, of course, kata. Just remember your medical terminology, guys. Kata means down, under, right? To break down, to break under. I'm catabolizing myself before your eyes right now. I have not eaten breakfast yet, and I have not had time to eat anything for lunch. I've had a Diet Coke. That's about all I've had. I haven't had time to do any food. But my body still needs energy. And so what my body is doing is catabolizing the stored energy, putting that into circulation so that my cells are still getting paid to work.
You look great.
Thank you. After a week, almost 2 weeks, my scrubs are fitting a little bit better. I can't admit that. My scrubs are fitting not quite as spandex tight as they were a couple of weeks ago. So I'm happy with that. All right, let's talk about fats. Lipids. We've got some different classifications of lipids. And again, we're going to get into really great detail when we get into nutrition. Right now, we're just kind of going over the basics. Neutral fats, phospholipids, steroids, and eicosanoids. That's how you say that fourth word. Eicosanoids. I think this is all review from yesterday. I remember talking about the bobby pin shape of the eicosanoids. So these neutral fats, this is where you have the bonds. These are your nutritional fats. Saturated fatty acids only have what kind of bond?
Single?
Yeah, single bonds, hooked on phonics. Single bonds. So how much energy would I have to expend to break a single bond versus a double bond? Less. So if I'm eating a lot of saturated fatty acids, I'm not using a lot of energy. I'm getting a lot of energy. Fat gives us the most amount of energy of any of our nutrients. So I'm getting this much energy, but I'm only using this much energy. Where does all of this go? Storage unit. Now, if I start feeding a polyunsaturated, meaning a molecule that has multiple double bonds, suddenly now my body's having to use a lot of energy, and I'm not going to have any or as much to go to the storage unit. So it's not that saturated fatty acids are really bad for you. I mean, you need fatty acids. It's that they're more easily and readily put into the storage unit. That's going to get to be very important when we talk about obesity management in our companion animals. So here we have our saturated single bonds. Why does this bond not count, even though it is a double bond? Because it's not part of the hydrocarbon chain. Here we have our unsaturated. If there's only one, sometimes we'll call it mono-unsaturated, meaning one double bond. And the location of that double bond is going to tell my body what to do with it. There are some fatty acids I'm willing to bet that you guys have heard of before. Omega-3, omega-6. Well, why are they called that? Because 1, 2, 3, omega-3 has the very first, it doesn't have to just have one bond, but it has the very first double bond here at the third carbon. Your body takes a look at where that first double bond is and says, okay, ding, 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 this is what we have to do with this. Omega-6 is called omega-6 for why? Because the double bond is at the 6. 1, 2, 3, 4, 5, 6. First double bond is here. You probably heard of omega-6. It's what is infused in like shampoos, creams, fingernails, stuff like that. It helps with your hair and nails and skin. Phospholipids. This is the skin of our cell, the phospholipid bilayer. We have hydrophilic facing the outside, hydrophobic facing the inside. And this is what regulates stuff getting in and out of your cells. Steroids are also an example of a type of lipid. I'm not going to have you reproduce this, don't worry. But we've already talked of one of these naturally occurring steroids, and that would be cortisol. Remind me when we produce cortisol.
You're scared.
Scared or stressed. Yeah, it comes from your adrenal glands, and that is going to be to help combat anxiety.
Cholesterol is what, right?
Cholesterol is also a steroid. Cholesterol is not so much for stress. The main thing that we use cholesterol for, at least on a cellular level, is to help make the structure of the cell membrane a little bit more rigid. It helps to prevent destruction of that cell membrane. Eicosanoids, really the only thing I need you to know is it's got this bobby pin appearance. We're not going to go into prostaglandins, thromboxane, and leukotrienes. That's just so you've heard those words before. And when you get into clinical pathology, when you get into canine feline disease management, you've heard these words once before. All right, proteins. Proteins are the most abundant organic molecule in your body. Proteins are made of these structures called amino acids. And amino acids, think of them like Legos. If I give you a giant bucket of Legos, what could you make with them? What could you make with a bucket of Legos? A robot. You quite literally anything. I could make anything out of Legos. That's the whole idea behind proteins. When you eat the Chipotle chicken burrito, your small intestine, so that chicken has got a whole bunch of different types of Legos. Every amino acid is represented by a different color, shape, or size of Lego. So I can take a bunch of different Legos, put them together, make a protein. That protein I swallow, hopefully on the first try this time, and my small intestines are going to bust apart the Legos. Because the Legos, just like my other nutrients, have to be single. But then what my body's going to do is it's going to take those Legos and reassemble them into other things. It's really pretty cool. So these proteins are going to make things like muscles, smooth muscle, cardiac muscle, skeletal muscle. They're going to make different hemoglobin, which is the transport in your red blood cells. It's going to make other different kinds of proteins. It's also going to help with your nucleotides, which is your DNA on a most basic level. The 3 nucleotides are amino acids. So our bodies can take those Legos and really turn them into anything. That's what our second or our next chapter is going to be, is that our bodies produce a recipe. It feeds the recipe into a factory. The factory just pulls these Legos out of the sky and reassembles and bakes the cake. It's really no different than baking a cake. I get out my book, I get all my ingredients, I put them together in a specific way, bippity boppity boo, I've got cake. Well, maybe my body is wanting to make some kind of specific complicated protein. RNA takes the message, I gather all of my ingredients, I put them together in a specific way, bippity boppity boop, I have a brand new complex protein. I am not going to ask you to list out these amino acids, not yet.
Can you go back?
Of course I can go back, yes, absolutely. So when we get to nutrition, we are going to be talking about these specific amino acids, what they do, how do they combine, what do they make, that sort of thing. For right now, though, I'm just going to introduce you. It's just so in nutrition, you've heard it before, right? We're beginning pathways. The brain's going to think about it. Then when we get to nutrition, it's not a completely foreign concept. Where are you guys in med term right now?
We're doing body fluids,
Body fluids.
Yeah, we today.
Have you been taught the rules yet?
The what?
Rule. We have 3 primary rules here at the Vet Tech Institute, and then going forward into your careers.
No.
No? Oh my goodness. Okay, well, while you're finishing your notes, I will tell you the 3 rules. Rule number 1 is don't panic. Don't panic. There are going to be times when you're going to want to panic. In school, it might be when you're trying to get your first jugular stick. You're going to get that flutter. When you get out in the clinic, it might be a difficult surgery. For me, I can remember very, very vividly, probably the last time I truly panicked in veterinary medicine. I was doing a salivary mucocele resection on a boxer with my doctor. Salivary mucocele is seal, cyst, salivary, and it's just usually benign tumor. And we don't usually even do anything about them, except it was gotten so big that it was affecting his ability to chew. And it got in there, and it had actually tendrilled and wrapped around his jugular and his carotid. So what we ended up having to do was we were going to have to debulk it, where you're just pulling out bits of tissue. But we couldn't save the jugular or the carotid. So what we were going to have to do is ligate, meaning we're going to tie it off above and below, and then clip it. And then it remains tied off, and the blood doesn't go and use that highway anymore. So we did that for the jugular, no worries, no problems. This is like an 80-pound boxer. He was humongous. We can't find the carotid artery. This thing should have been bigger than the size of my thumb. So we're looking. We see something, but it's like super, super thin. This tiny little pink little thing. And I was like, hey doc, there's no way that could be the carotid. And he's like, I don't know, I can't find anything else. I said, well, let's see, let's try and blanch it. Blanching is where you push on it, you let up, and you can see the blood running back into it. That's how you're doing your capillary refill times. It didn't blanch. So I was like, well, let's see if it's one of the cranial nerves. Strum it. So he strums it like this, like a guitar string. And if it had been a major nerve, the dog's face, even under anesthesia, would go. Didn't do anything. I'm like, okay, well, it's not a nerve. Doesn't look like a blood vessel. Cut it. And he went, okay.
Oh, God.
Well, I was like, well, I meant ligate first. So we're both standing there. We're looking to see what's going to happen. And suddenly, and I'm like, when in reality, I probably just could have done this. It's hitting the wall. The dog is, no word of a lie. The dog is on this table. And it's hitting the wall. That's how much blood pressure is in the carotid artery. And so I'm like, and I did panic a little bit. And then we both looked at each other and said a couple of profanities. And then we got to work. And the dog did fine. The dog did just fine. The dog survived. No worries at all.
So were you meant to cut it?
Well, yeah, we meant to cut it, but not without ligating it first. We wanted to tie it off first. When you ligate something, this is all giving you a little glimpse into your careers as technicians. Here's my carotid artery. I want to tie it off here. I want to tie it off here so that the blood coming from the heart meets a roadblock. And the blood coming from the brain meets a roadblock. I got another one. He's fine. It's just for oxygenating the brain. And honestly, it's a boxer. Who's going to know if he's got a little bit of brain damage? No, I'm kidding. I'm kidding. I'm kidding. I'm totally kidding. Do not miss the Hamilton. Miss some hates boxers. No. But what I want to do is tie it off, because we didn't tie it off. Boop, boop. We just cut it. We transected it. And suddenly, the entire pressure from the head and from the heart is now spurting out of these two cut ends of the carotid artery. I panicked. So rule number 1, don't panic. Rule number 2, don't eat poo. Don't eat poo. Yeah, and actually I may have made a mistake. That one actually might be rule number 1. Don't eat poo. Now, am I saying you get a cereal bowl and you're shoveling it in your pie hole? No. I'm saying be, especially right now, wash your hands. If I do a puppy examination, I run a fecal exam. I stir the fecal into the fecal salt solution, and I've had a super busy day. I haven't had time to sit down and grab my sandwich. So what I do is while that fecal is cooking, I'm gonna run over and grab a bite of my sandwich. What did I just do? I just ate poo. And a lot of bad things can infect you from dog poo. Zoonotic. Rule number 3. Rule number 3 is you will never, ever, in the history of ever, if in your career you ever do this, I will hunt you down. I will punch you in the throat. I have that on the recording. The medical file is a legal document. You will never, ever in the history of, I know I'm wagging my finger at all of you. You will never, ever write the word pussy in a medical file.
Mr. Mayor just brought that up. Did somebody do that recently?
No, that's just a common life lesson. You don't write the word pussy. It is purulent discharge. You can say that something is pus. What? I think it's like that. Purulent, meaning thick. Or you could say that it is, let's use your med term, pyogenic, meaning pertaining to forming of pus. Never write pussy. Those are your 3 rules. All right, so this is the, do what?
Did you ever make that mistake?
No, I did not. I have seen OJTs. What is an OJT? On the job trained. I've seen them do it.
I was thinking about G and I was like, what's that?
Yeah, OJT, on the job trained techs. All right, these are the amino acids. We're going to go into these in detail. That's all you need to know right now, that there's a lot of different amino acids. And then the structure. Okay, the way that the structure of these proteins is helps the body recognize what I need to do with it. The first thing I'm going to do when I'm building a new protein is I'm going to take all of my Legos and I'm going to line them up. This is known as the primary structure. I get my Legos, I followed my recipe, I am now lining them up together to make a chain. The second thing I'm going to do is I'm going to take that chain and I'm going to allow the natural bends to happen. No different than if you have a cord that has been wrapped. You know, you unwind the cord and then it has a natural memory that it wants to be wrapped in. Same thing here. I have my primary structure. I have put all of my amino acids into a chain. My secondary structure, I allow any natural bends to occur. Third is my tertiary. What this means is I now take this protein, I'm going to do my little delicate origami folds. That's how I make a protein. I start with my primary structure, chain of amino acids. I take that chain, I have my secondary structure where I'm allowing the natural folds to occur. My third tertiary structure is where I am making additional folds to tell the body specifically what to do with it. I can take 2 of these origami proteins and bind them together, and what that's called is a quaternary structure. So the first 3 are how I fold and create a new protein. The 4th one is what is it called if I have more than one of them bonded together. What questions can I answer for you about this right now? Yes.
So what's the purpose of people taking BCAA?
Taking what?
Taking BCAA, branched chain amino acids?
These.
BCAA, branched chain amino acids? Like
I,
they could get one, it's like a powder, almost like protein or something that you mix with water and you take it while you work out.
a lot of stuff I teach you is transferable to humans. That one is not.
Okay.
We don't use anything like that in animal medicine, so I honestly, that's one that has stumped me. I know why they take creatine, stuff like that, which is one of the amino acids, but I honestly have no idea what that one is. So again, primary structure, get the amino acids, put them together in a chain. Secondary, allow the natural bends to occur. Tertiary, make the little delicate origami folds. Quaternary, I have two, and I bond them together. Comments, questions, concerns? How about any of you from the TV audience? What?
I have a project like origami.
Oh, I've got a picture coming up to show you.
Tertiary.
Tertiary and quaternary.
You said those two are the bend?
No, primary is where I take the amino acids and I string them together in a chain. Chain. Secondary, I have the natural bends. Tertiary is where I'm creating an overall unique shape. Quaternary is when two or more of these are connected together. Quaternary is two chains together. Yep. So let me show you a picture, because I think all of you are pretty visual. The first thing I've done is I take my amino acids and I hinge them together in a chain. I take that chain and I allow these natural bends to occur. Then I take that and I make these very specialized origami folds. This is now a complex protein. I can take two of those, bond them together, and that's the definition of the quaternary. These three steps are making one of these. So I had to do these three steps to make this guy. I had to do these three steps to make this guy. And when I bonded these two together, that made a quaternary. I do have a video on my website. So if you want to go in and see a little bit more about this protein folding, you can go in and double check that. Structural proteins. These are exactly what they sound like. They create structure. Collagen. Somebody tell me what collagen is. You've heard this word before. Well, it's a protein in your connective tissue that helps maintain the elasticity. Unfortunately, gravity works. And gravity is constantly pulling on your skin. And what that does is it loosens this connective tissue. So you go get collagen injections, right? It tightens it up, makes it much more firm. Keratin. Keratin is a structural protein that gives you your hair and your fingernails, horns, antlers. And finally, we have actin and myosin. These are two structural proteins that we'll talk about in great detail when we get to the muscular system. But actin and myosin, so let's take my muscle right here, my bicep. And I have actin and myosin filaments that are kind of interwoven like this, very loosely. And when my brain sends a message to my bicep that says, I want you to contract, these now filaments ratchet over each other and contract towards the middle. So like this, here's my one group of actin and myosin, here's my other group of actin and myosin, And you can see that as they contract towards the center, it causes my muscle to contract. So these are the proteins that allow us to move. I can't hide from the owl in here as easily as I can in room 200. I play hide and seek with the owl in 200 sometimes. Sometimes it's just for me. All right, so we have a few other functional proteins. Let's talk about these hormones. Oh, yep, absolutely. Not a problem. No worries. Everybody else okay? Or do you need me to stay on the slide for a minute? You guys are good? All right, so let's talk about some of these other functional proteins. Well, we have hormones. Hormones control pretty much everything in your body. Hormones are produced by glands. Now, obviously, when you think of the word hormone, you think of like puberty, estrogen, testosterone, progesterone. But we do also have hormones that do things like control your metabolism. How efficiently do you use food? You have hormones that control your fight or flight. You have hormones that are released after you eat a big meal. You have hormones that are released when your kidneys need to signal for your body to make more red blood cells. So it's really the control centers of your body. Antibodies are another functional protein. And I want to talk about this for a second because this is where we can start to take these abstract definitions, boring, 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 but we can start applying it to something that we're dealing with right now. Antibodies is a word that is now in the news pretty much every day, all day long. But what exactly is an antibody? It's actually pretty interesting. So what an antibody is, and you know I'm insanely visual. So the way that I picture an antibody is it's a private investigator that has a wanted poster. So I'm going to use a disease. I'm not using the C word disease that you're thinking of. I'm going to use a different C word disease, chickenpox. How many people in here have had chickenpox? Seriously? Two. Two and me. All right. Well, that just kind of proves my point. So what happens is when you get the chickenpox, your immunity group is looking down, the virus is coming in, nobody's detected it, nobody's looking for it. It's kind of the danger right now of the COVID. And this villain, this foreign invader comes in and he's like, and nobody's looking for him. Nobody even knows that he's not supposed to be there. Suddenly, immunity group goes, oh my God, stranger danger, stranger danger. And he sends in your white blood cells, which are your army. He's watching what happens. He's watching what happens. He's taking a sketch. Now he has a private investigator with a picture of that virus. And that private investigator's only job is to hunt down that one guy. And if that one guy shows up on his turf, call in the military immediately. And immunity group already has the battle plan because we already know what defeated him. That's why when you get chickenpox, you never again get chickenpox. It's not that you never again get exposed to it, but we've got this private investigator that immediately goes, chickenpox virus, warning, warning, off it goes. The danger with viruses, though, is that they can mutate, and that's the big danger right now with this COVID. COVID mutates faster and more dramatically than any other virus we've ever experienced in history. That's what makes it terrifying. It, in the last 5 months, has mutated a minimum of 4 times. That's unheard of. We don't know how to deal with that. What it means when a virus mutates is the same thing as chickenpox. You still get exposed to chickenpox, but now, whoop, Chickenpox has a facelift. Chickenpox goes and gets plastic surgery. Now the virus comes in. I got my PI looking for chickenpox, don't I? But I see this guy, that don't look like no chickenpox. And he just keeps on walking because I don't got anybody for this guy. This chickenpox virus, though, does a similar infection, slightly different, though. The plastic surgery has altered him. So instead of just the itchy bumps that you get, chickenpox when you're a kid, it's really pretty benign. It just makes you itch. Chickenpox later on after the facelift, a little more serious. It's a condition called shingles. It's unbelievably painful. That's the big issue with COVID right now, and that's the big issue with a vaccine. What a vaccine does is it tricks your body into thinking stranger danger. I get the vaccine, my body goes, oh my God, stranger danger. We make the antibody. I now have this protection, and I'm gonna go and I know exactly what to do to combat that foreign invader. The problem is that COVID is getting facelifts faster than we can map it. The minute we come close to a vaccine, he changes. Then we get close to that vaccine and he changes. Just when there's all this argument, I know I've gone off the rails, but that's okay, guess what? It's my class, I can do what I want. You have all these people that are like, I'm not wearing the mask, I wanna get herd immunity. Well, that's fabulous. You're gonna get COVID once, you'll have the antibodies, but then it's gonna mutate. And nobody in the population is protected from the mutated version. And then it mutates again, and every time you get it, it's causing more and more damage to your lungs. So antibodies, super important functional protein.
I heard that you can, when you get the chickenpox vaccine, you can still get chickenpox.
Kim, what? I didn't get any of that.
When you get the chickenpox vaccine, you can still get chickenpox.
Yeah, you can get shingles, and you can get chickenpox. However, the glasses keep fogging up today. Because you have the wanted post, so I give you the chickenpox vaccine. It doesn't mean that you're never coming in contact with chickenpox ever again in your life. You will. But because you already have the wanted poster and you already have a battle plan, it means that your body will fight it off faster and your symptoms will be less. So it's not going to be as serious of an infection as it would be as if you were fighting it off for the very first time. Does that make sense? Yeah, but it would have been, it's why it's important, because you as adults, chickenpox can actually be pretty serious. So giving you the vaccine already gives you a game plan. So if you get it, you have already got a plan to deal with it. Versus somebody who wasn't vaccinated, who has no idea what to do with that, and chickenpox is just gonna run rampant. So those are antibodies. I find immunology really interesting. And the way that our body fights off infection, I find that all very fascinating. Yeah, functional proteins just mean that they do or control something within your body. Structural proteins, my fingernails. My fingernails are not really doing anything for me. I could pluck off all of my fingernails and really have nothing more than a little bit of a bad day. Functional proteins, however, are controlling stuff in your body. They are doing active things in your body. Enzymes are known as a catalyst, where they are going to initiate different reactions within your body. So these functional proteins are doing jobs. Structural proteins are just doing that. They're just giving you structure. Hair, nails, horns, antlers, hooves. Functional proteins are actively doing jobs. So I find immunology pretty interesting, especially right now. Because although there's no arguing with stupid, there's no arguing with stupid. I tried once, And they drug me down to their level and then beat me with stupidity experience. So, because the whole argument, right, is this mask is not protecting me from anything. Well, my argument was I pray the next time you have surgery, for the safety and well-being of your doctor, please request they don't wear a mask. Because the mask is obviously a detriment to him, and you're telling me that it does nothing. So please, for his health and safety, tell him not to wear one. And then maybe he'll just shuffle off into the shallow end of the gene pool. All right, so enzymes, as I said, are just a catalyst. Catalyst is just something that speeds up a chemical reaction. Most of these enzymes are going to end in ACE. So example, lipase, amylase. These are digestive enzymes. You have polypeptirase, acetylcholine esterase. They're fancy names for I'm putting a match to the fire. I am initiating some sort of chemical reaction. Give you guys a minute. Furious with writing. What sorts of dogs did you learn about today? What? No, there's not one called God that I'm aware of.
So many dogs. Weimaraner?
Oh, the Wymi, the Vizsla.
What is it called? Vizsla?
Yeah, the Vizsla. Which looks like a red Wymi. It looks like a mahogany Wymi. They have the same body type. They're a little bit smaller.
Found out that mouse silver is a milk.
Yes. So is blue. Rust. You also have doppels, double doppels. Yep. Brindles. Brindle is the one that looks like tiger stripes. All right, so this is just a picture of these enzymes that are initiating, putting a match to the fire. The way that we are going to start a reaction is very similar to, oops, get in the right camera, this. My car key. My car is the reaction that needs to be started. This is the enzyme, the catalyst that's going to do that. If we look out in the parking lot, my car is just quietly waiting for me. It's not hopefully, it's not doing anything. If I take this enzyme, I take this car key, and I go to any other car in the parking lot, what's going to happen? Nothing. Is not going to do anything. But when I go to the one that it fits, I start the reaction, I start my car, and now I can make it go. That's the same thing here. It's like a lock and key. Time flies when we're having fun. We're going to talk about nucleic acids tomorrow. We're going to finish this up tomorrow. We're going to talk a little bit about DNA. Any comments, questions, concerns from my TV gallery audience? Everybody's okay? Now you know about antibody protection. That's pretty cool. So I'll see you guys online tomorrow. And for my live studio audience, I will see you guys live on tomorrow.
We all